Welcome you all for this today's session. In this session, we are going to discuss three things. One is evaluation of expression, operator precedence, and the type conversion. Okay, these three concepts are very important in the C programming language. So, here I have considered two examples. Expression, how this expression can be evaluated in the computer. So, when we give this expression to the computer will execute this expression based on the precedence and the associativity. Based on the precedence and the associativity. Precedence means priority of the operator. So, first the higher priority operator execute first, later the lower priority operators. Then the associativity. If two operators of the same precedence, then how that operator evaluate. Example, if in case A plus B plus C, plus is the same operator, it has equal precedence, so it evaluate from left to right. If in case A plus B minus C, plus and minus both have same priority, once again it evaluates from left to right. If in case A plus B into C, now into is the highest precedence. So, first multiplication will be execute, later addition will be performed. So, to evaluate the expression, we need to consider the priority and the associativity of the operator. Okay, let us consider this example. Okay, in this example, the example contains arithmetic operator and the brackets. So, in C language, the highest priority is for the expression which is present inside the bracket. So, in C language, the expression which is present inside the bracket got highest priority. Okay, now consider expression 1, that is 8 modulus 5. One more expression 15 minus 3 and 4 plus 2. 4 plus 2. Here you see the brackets 1, 1. So, this is the outer bracket. This is 1. Then there is one more inner bracket. This bracket is 2. Then 3, 4 and 5. Okay, first outer bracket, one more inner bracket and one more inner bracket. So, when we evaluate the expression, so highest precedence for the expression which is present inside the bracket, in the bracket, so innermost expression got the highest priority. So, here 15 minus 3 and 4 plus 2 got highest precedence because these are the inner expressions. So, here it got highest precedence, then first 15 minus 3, later 4 plus 2 will be evaluated. So, 2 into 8 modulus 5 into 4 plus 15 minus 3, that is 12 divided by 4 plus 2, then one more bracket. Next, here there is one more inner expression, that is 4 plus 2, 8 modulus 5 into 4 plus 12 divided by 4 plus 2 is 6, close bracket and close bracket. So, here first 15 minus 3 is evaluated, later 4 plus 2 is evaluated. Next is the next expression is 8 modulus 5. So, 2 into 8 modulus 5 is remainder 3 into 4 plus 12 divided by 6. Okay. In the next expression, here next innermost expression is 4 plus 12 by 3. Here plus and division operation. Plus and division operation. Here highest precedence is for division operation. So 4 plus 12 divided by 6. So 12 divided by 6 is 4 plus 2 2 into 3 plus 4 plus 2. So 12 divided by 2 is 12 divided by 6 is 2. Next is the innermost expression. Next is 2 into 3 into 4 plus 2 is 6 close bracket. Next innermost expression means the expression which is present in the bracket is 6 into 3. So 2 into 3 6 18. Next, last is the 2 into 18. So 2 into 18 is 36. So the final evaluation of this expression is 36. Okay. So when we are evaluating the expression in C, first preference is for the expression which is present inside the bracket. If more expressions are present in the inside the bracket, then innermost expression got highest priority, so it will be execute first. So in this example, 15 minus 3 and 4 plus 2 has highest precedence. So first 15 minus 3 will be evaluated, later 4 plus 2 will be evaluated. Later the next higher level expression will be evaluated. Like that the expression will be evaluated. Then the operator. So here in this expression, multiplication, division, addition and subtraction and modulus. So all 5 operators are present. So in arithmetic operator, highest precedence is for multiplication, division and modulus. Next precedence is for plus and minus. So here the division operation execute first, later modulus, multiplication and subtraction and addition. So after evaluating this expression, the final result is 36. Okay, this is a way of executing the expression or the evaluation of the expression.
Just now I explained how the expression can be evaluated. So now I am going to explain how we can execute C program and online. So if you want to execute your program through online, go to Google, type online C program execution. Online C program execute online C program. Okay, here you have one tool. The tool name is onlinegdb.com. So here you select this online C compiler, the online gdb.com. So here you will get an editor. This area you can write your program. Okay, here I try to execute one program, that is addition of two numbers. Program to find sum of two numbers. Okay, right, type. Then if you want to find sum of two numbers, you need two numbers. So I'll write int a, b and sum is equal to 0. Next, printf, enter the values for a and b. Okay. Next, this statement for printing the printf, enter the value statement. Now if you want to read the values from the keyboard, you need to use a function scanf. So SCANF scanf. So syntax is scanf within double quote control string comma variable is. So here I am reading two values of integer type. So that's why I'll write %d %d. So %d indicate two integer variables. So address of A comma address of B and semicolon. Now we have read the values. After reading the value, we need to perform addition. So for the addition variable, I have declared the variable sum. So sum is equal to A plus B. Sum is equal to A plus B. After finding the sum, we need to display the result. So I'll write printf sum of two numbers is equal to %d is equal to %d slash n double quote close comma. Here %d indicates integer value. So sum is also stored in the variable of type integer. Now I'll write sum, then semicolon end. So now to run this program, here there is a button that is run. Otherwise you can write press F9. So click run button. Now here after executing, clicking run, here the window will be show enter the value for A comma B. This is a console window. Here you can enter the input and the output will be displayed in the portion. This area is the editor for typing the program. So I'll enter two values 2 and 5. So output is 7. So sum of two numbers is equal to 7. Okay. This is a way we can execute C program online. So go to Google, type execute online C program. There you select onlinegdb.com, onlinegdb.com. So there you can enter the program. After entering the program, you can execute the program by clicking run button. By clicking run button, you can execute the program. Okay. Now just I explained the evaluation of the expression. Now I'll execute to the evaluation program. Okay, this is the expression I have evaluated, that is 2 into 8 modulus 5 into 4 plus 15 minus 3 divided by 4 plus 2. So in this expression, so the first preference is for 4 plus 2, second preference is for 15 minus 3, then 8 modulus 5. So after writing this program, I'll execute this program by pressing run button. Now the output of this expression is 36. Output of this expression is 36. Similarly, we can execute the programs in this flat form.
Next expression 100 divided by 20 less than equal to 10 minus 5 plus 100 modulus 10 minus 20 equal to 5 greater than 1 not equal to 20. Okay, this expression contains division operator, relation operator less than equal, plus modulus, and relation operator equal, not equal, and greater than or equal. So here the expression contains both arithmetic operator and the relational operator. So when we are evaluating this expression, first preference is for the arithmetic operator. In arithmetic operator, first preference is for multiplication, division and modulus, later addition and subtraction. So in this expression, first is the highest precedence is for 100 divided by 20. So 100 divided by 20 is the first preference. Next preference is 100 modulus 10. Next addition, subtraction, addition, subtraction, and the relational operation evaluation. Okay, first evaluate. So first evaluate 100 divided by 20. So 100 divided by 20 is 5 less than or equal to 10 minus 5 plus 100 modulus 10 minus 20 equal 5 greater than or equal 1 not equal 20. 1 not equal 20. Okay. Now we evaluated 100 divided by 20. Next expression is 100 modulus 10. So 100 modulus 10, it returns a remainder value. So remainder value is 0. So 5 less than or equal to 10 minus 5 plus 0 minus 20 equal 5 greater than or equal 1 not equal 20. Not equal 20. Hello? ಹಾಂ 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 ಸರಿ ಮಾಡ್ತೀನಿ. ಹಲೋ ಸರ್ ಬಂದಿದೆ ಅಲ್ಲಿ ನೀವು ಇನ್ನೂ ಬಂದಿಲ್ಲ. ನಾನು ರೆಕಾರ್ಡಿಂಗ್ ಇತ್ತು 8:30ಗೆ ಕೆಳಗಡೆ ಬಂದುಬಿಟ್ಟೆ. ಅದೇ ನನ್ನದು ಡ್ಯೂಟಿನ ಅದಕ್ಕೆ ಆಲ್ಟ್ರ್ ಮಾಡಿದ್ದೀನಿ ಸರ್. ಹಾಂ ಸರಿ ಸರ್, ಥ್ಯಾಂಕ್ ಯು ಸರ್. Okay, here 5 less than equal to 10 minus 5 plus 0 minus 20 equal 5 greater than equal 1 not equal to 20. Okay, now here we have executed division operation and modulus operation. Next is the subtraction, addition, subtraction operation. So here both operators have the same precedence, same priority. So the evaluation starts from left to right. So when you evaluating this expression left to right, so that this will be 5 less than or equal to 10 minus 5. So 10 minus 5 is 5 plus 0 minus 20 equal 5 greater than or equal to 1 not equal to 20. Okay, next is 5 plus 0. So equal 5 less than or equal to 5 plus 0 is 5 minus 20 equal 5 greater than or equal to 1 not equal to 20. So here one more arithmetic expression, that is 5 minus 20. So here 5 less than or equal to 5 minus 20 means minus 15 equal 5 greater than or equal 1 not equal 20. So here first we executed division operation, modulus operation, later subtraction, addition and subtraction. So, here in the result it contains only the relation expression, that is less than equal to, equal equal, greater than equal and not equal. Okay. First is in the relation expression, first preference is for less than equal, greater than, less than greater than, less than equal to, greater than equal to, equal to, not equal to. So, less than equal and greater than equal as same precedence. So, first it will evaluate 5 less than equal to minus 15, 5 less than equal to minus 15. So, minus 15 is lesser than 5. So, this condition is false. So, it will assign 0, equal 5, less than, greater than equal to 1, not equal to 20. So, next relation expression is highest precedence is for greater than or equal. So, 5 greater than or equal to 1, greater than or equal to 1, here condition is true. So, this will be 0, equal 1, equal 1, not equal to 20, not equal to 20. So, here 0 equal to 0, this will be 0 and not equal to 20. 0 not equal to 20, yes, conditions true, will be 1. Condition will be evaluated to 1. Okay, this is a way of evaluating the expression. So, when we are evaluating the expression, we need to consider two things. One is the precedence and the associativity. So, precedence is the hierarchical order of the execution of the statement. So, in the precedent, it will give a priority to each operator, priority for each operator. So, based on the precedence, based on priority, the expression will be evaluated. So, when we are evaluating the expression, so highest precedence is for the expression which is present inside the bracket. So, innermost expression gets highest priority, then the outer expression gets the lowest priority. So, after evaluating the innermost expression, next expression will be evaluated based on the priority of the operator. So, in C language, first preference is for brackets, open bracket, and the next precedence is for unary operator plus plus minus minus, complement, star, minus, addition, size of, got the next priority, and the next priority is for arithmetic operators. In the arithmetic operators, first preference is for star, means multiplication, division and the modulus operator. Next precedence is for addition and subtraction. Next is the bitwise operator. Next is the relation operator, less than, greater than, less than equal to, greater than equal to, equal to, not equal to. Next priority is for logical operator, logical and logical are, and bitwise and bitwise are, left shift, right shift, and the complement is a unary operator. So, that will be executed at the higher level. So, last priority is for the assignment operator. So, either it may be a shortened assignment operator or the equal operator. So, in C language, highest precedence is for the expression which is present inside the bracket. Okay. Okay, let us consider one more example. The example is a plus 2 greater than b or not complement, not c, and a equal to e or a minus 2 less than e, where a is equal to 11, b is equal to 6, c is equal to 0 and d is equal to 7, e is equal to 5. Now, you convert, you assign the value of a to the expression. So, the value is 11 plus 2 greater than 6 are not 0 and 11 equal 7 are 11 minus 2 less than equal 5. Okay. This expression consists of both arithmetic operator, relation operator and logical operator. So, this expression consists of arithmetic, relation and logical expression and unary operator. So, here the first preference is for the unary operator, that is a NOT operator. First it will be evaluate. So, after evaluating the expression, the resultant expression is 11 plus 2 greater than 6 or, so 0 complement 0 naught is 1 and 11 equal 7 or 11 minus 2 less than equal 5. So, first unary operator, first it will evaluate. Next is 11 plus 2, then 11 minus 2 is the arithmetic expression. So, here addition and subtraction got highest same precedence. So, it will evaluate from left to right. So, first it execute 11 plus 2, that is 13 greater than 6 or 1 and 11 equal 7 or 11 minus 2 less than or equal 5. Okay. Here first addition will be evaluated. Later one more expression, that is arithmetic expression, is 11 minus 2. So, here 13 greater than 6 or 1 logical and 11 equal 7 or 11 minus 2 is 9 less than or equal 5. 9 less than or equal 5. So, here arithmetic expression 11 minus 2 is evaluated. Next is in this expression left with relation expression and logical expression. So, one relation expression is 13 greater than 6, 11 equal 7, then 9 less than or equal 5. Less than or equal 5. So, first it will evaluate 13 greater than 6. 13 greater than 6, yes, this condition is true. So, it will be assigned 1 R 1 equal, and 11 equal 7 or 9 less than or equal to 5. So, this is 1 R. Next, we left with equal expression and less than or equal to 5 expression. So, here in this two relation expression, highest precedence is for relational expression, that is less than or equal. So, after evaluating this expression result will be 1 R 1 and 11 equal 7 or 9 less than or equal to 5, condition is false. So, this will be 0. Okay. Next is one more relation expression, that is 11 is equal to 5. So, this expression will be evaluated 1 or 1 logical and. So 11 equal to 7, here this condition is false. So the result will be 0, 0 or 0, 0 or 0, 0 or 0. So now we left with logical operators. Okay, we left with logical operators. So both are logical expression. So in this logical operator, first preference is for logical AND operator. So here 1 or, so 1 0, 1 0 means in the logical AND operation 0, 1 0 0, then or 0, 1 1 0 is 0 and 0. So here both operators are the OR operators. So first it will evaluate 1 or 0. So in logical OR operation, any one of the expression is true, so output will be true. So 1 0 is 1 or 0. So 1 or 0, that is 1. So after evaluating this expression, the output will be 1. So when the expression consists of arithmetic, logical and relational and unary operator. So first preference is for unary operator, next preference is for arithmetic operator, next preference is for relation operator, and the last preference is for the logical operator. So this is an example. This example for evaluating the expression. Okay. Similarly, we can evaluate other expression by following the precedence and the associativity rule. Okay, the next important topic is the type conversion. So type conversion, the name itself indicates we can instruct the compiler about converting one data type to another data type. So when we executing the program, we convert one data type to another data type. So we already know that C language supports 5 different types of data type. 5 different types of data type. One is integer data type, float data type, double data type, character data type, and the void data type. So once again, the integer data type also contains int, short int, and long int. So in integer, unsigned and signed, signed integer and unsigned integer. Float, double, long double, character, so character, signed character and unsigned character. So we have different types of data type. So sometimes we need to convert from one data type to another data type. So the process of converting one data type to other data type is called type conversion. Converting one data type to other data type is called type conversion. So in C language, it supports 2 types of type conversion. Two types of conversion. One is implicit type conversion. Explicit type conversion, implicit type conversion and explicit type conversion. Okay, let's consider implicit type conversion. So implicit type conversion means the conversion is done automatically. So conversion will be happened automatically based on the expression, In explicit type conversion, the user himself has to convert the expression. Okay, let's consider an example. The example is, I consider the variable float a is equal to 11.5 and res int m is equal to 5 and result 1. Result 1. Okay, now consider the expression. The expression is RES1. RES1 is equal to A into 5. A into 5. A into 5. Sorry, A into M. A into M. Okay, now this expression is the mixed type expression. This expression is mixed type expression because A is of float type and M is of integer type and RES1 is of float type. So, here the data will be converted to floating point data type because here the hierarchy is higher order data type. So, the conversion will be happen to higher order data type. So, in this the operator A is float and variable A is float and variable M is integer. So, the value of M will be automatically converted into higher data type value, that is float type value. So, here after the conversion the result will be floating point. So, this will be implicitly convert to float. Similarly, you consider this 1, 2, RES1 is equal to A into M. A into M. So, here the variable is RES1. RES1 is of integer type. RES1 of integer type. A is float and M is integer. Here it will performing the arithmetic operation and the value still the value of M converted into float, but the resultant value is assigned to integer variable. Resultant value is assigned to integer variable. So, here the fractional points will be eliminated. So, fractional value will be truncated. So, there is a problem of implicit type conversion. So, when you performing this operation, so fractional points will be eliminated or fractional points will be truncated. Okay. Next, you consider one more expression. The expression is, I will consider the variable float AVG. Float AVG, int A is equal to 10, B is equal to 21. B is equal to 21. Now, average is equal to A plus B divided by 2. A plus B divided by 2. When you performing this operation, the output will be AVG is equal to 10 plus 21 is 31, 31 divided by 2, 31 divided by 2. So, the value will, the actual value is 15.5, 15.5, but when we executing this expression, the result will be stored as AVG is equal to 15.0. AVG is equal to 15.0 because 31 is of integer type, 2 is also of integer type. So, when you performing integer division operation, it will truncate the fractional values. So, when you truncating the fractional values, it stores only 15, but the variable is of floating point type, so it will assign 15.0. So, this is the problem of implicit type conversion. So, implicit type conversion, the conversion will be performed automatically. Okay, I already mentioned sometimes we need to convert this into required data type. Okay, I consider this example itself. This example, now I want the fractional points. Here average is equal to 31.31 divided by 2. So here I need to get 15.5 itself. So here we need to convert the convert the expression. So in order to convert this expression, we can use explicit type conversion. In explicit type conversion, we need to use a casting operator, that is type casting operator. We need to use type casting operator to convert operator to type conversion. Okay, here the syntax is data type and the expression. Data type and expression are the data type and the variable. Okay. Now here I'll consider this value, this variable. So AVG is equal to int, conversion to float of a plus b divided by 2. So here the result of a plus b will be cast into floating point data type. So after this conversion, the result will be 31.0 divided by 2. So 31.0 divided by 2, so automatically, implicitly 2 will be converted into floating point type. So 2 will be converted into floating point. Next, this will be like this, 31.0 divided by 2.0. Now both are of the floating point type. Next, the output will be of AVG is equal to 15.5. Okay, this is the explicit conversion. So in the explicit conversion, the programmer itself convert the data from one data type to another data type by specifying the type conversion operator. So the type conversion operator must be present within the bracket. Type conversion operator must be present within the bracket. Okay, we consider one more example. So I have a value a is equal to 89.995. Now I want this value into the form of integer value. So in order to convert this value into integer value, so b is equal to int of a. Okay, if I write this int a, now this value will be converted into integer type variable. So int b is equal to int of a. So a is floating point value because it contains fraction values that will be converted into integer value. Okay, sometimes both operands are of integer type, but we want result in the form of discrete value, fractional value. Now then we need to convert into floating point data type. So there explicit type conversion is required. So in the implicit type conversion, the conversion will be happened automatically, depends upon the expression. So here the conversion will be performed to the hierarchical order, that is higher level. So if one in the expression, one variable is of floating point type, another variable is of integer type, so the conversion will be occur to higher level data type. Conversion will be performed to the higher level data type. Okay, this is the diagram of the type conversion. So the type conversion will be happen to lower rank to higher rank. Lower rank to higher rank. So lower rank is the character. So if the expression contains one variable is of character and another variable of shortened, so the conversion will be happen to shortened. If it is one operand is shortened and another operand is int, so conversion will be happen and it will be converted to integer type. So integer to unsigned int, unsigned integer to long int to unsigned long int to float, and float to double. So this is the hierarchical order of the type conversion. Okay, next topic is the precedence of the operator. So the precedence of the operator is important. So in C language, each operator is assigned with the priority and the associativity. Each operator is assigned with the priority. So the expression we already mentioned, the expression is evaluated based on the precedence of the operator, based on the priority of the operator. Okay, here the first priority is for the open bracket and close bracket. Second expression is the square bracket. So we use a square bracket during arrays and array variable declaration. Next preference is for the unary operator, that is increment, decrement, not operator, size of, complement, this assign positive number, negative number, and address operator and the pointer operator. So the next third priority is for the operators of unary type. Next preference is for the member operators. The member operators are star and pointer operator. So this operator we use in the pointers. So pointer manipulation, pointer operation, we use star operator and the arrow operator. So the arrow operator is the structure member operator. So we use this operator in structure member. Next is the arithmetic operator. So here arithmetic operators, 5 operators: star, division, modulus, plus and minus. Here the highest precedence is for star operator, division operator and modulus operator. Next preference is for addition and subtraction. Next, after the arithmetic expression, next preference is for less than and greater than, that is shift operators. Shift operators. So shift operators are bitwise operators. So next preference is for bitwise operator. Next preference is for relation operator. Relation operator. So relation operators are evaluated from left to right. So the associativity is left to right. So right to left. There are two types of associativity in C programming. One is left to right associativity and right to left associativity. So arithmetic operator, relation operator, logical operators, increment, decrement operators all are evaluated from left to right. The assignment operators evaluated from right to left. So the next expression is the relation expression, that is relation operator equal and not equal. Okay, this operator is used relation operator after the left less than equal, greater than equal. Next preference is for equal and not equal. Okay, this operator, single ampersand operator, is a bitwise AND operator, bitwise XOR and bitwise OR operator. So the next preference is for bitwise operators. bitwise operator, bitwise or bitwise and bitwise XOR or and the logical operator and or condition operator and the relational operator. Okay, this is the precedence for each operator in C programming. So every operator in C language contains the precedence. So based on the precedence, based on the hierarchy, the expression will be evaluated.